Welcome. Today we're diving into the world of IP addressing, a fundamental concept that powers the internet and all our digital communications. Whether you're browsing a website, sending an email, or streaming a video, IP addresses are working behind the scenes to make sure your data gets to the right place. In this video, we'll break down what IP addresses are, why they matter, and how they work. By the end, you'll have a solid understanding of the basics, setting you up for more advanced networking topics. Let's get started by exploring what an IP address actually is and why it's so important in our connected world. IP address, short for Internet Protocol Address, is like a home address for your device on a network. Just as your house has a unique address so mail can find you, every device connected to a network needs a unique IP address so data can reach it. Without IP addresses, computers wouldn't know where to send information, and the internet simply wouldn't work. There are different types of IP addresses, but at their core, they all serve the same purpose: identifying devices and enabling communication. Next, we'll look at the two main versions of IP addresses in use today. Most common type of IP address is IP4, which stands for Internet Protocol version 4. Introduced in the early days of the internet, IP4 uses a 32-bit address format, resulting in about 4.3 billion unique addresses. Each IP4 address is written as four numbers separated by dots, like 192.168.11. While this seemed like plenty at first, the explosive growth of the internet has made these addresses scarce. That's why a new version, IP6, was developed, but before we get there, let's see how IP4 addresses are structured. Four addresses are made up of four numbers, each ranging from 0 to 255, separated by periods. For example, 192.168.0.1 is a typical IP4 address. Each number represents 8 bits, so the whole address is 32 bits long. These addresses are divided into two parts, the network part and the host part. The network part identifies which network the device belongs to, while the host part identifies the specific device on that network. This structure helps routers and switches direct data to the right place efficiently. To solve the problem of limited IP4 addresses, IP6 was introduced. IP6 uses a 128-bit address format, allowing for an almost unimaginable number of unique addresses, enough for every device on Earth and then some. Six addresses look very different from IP4, using hexadecimal numbers separated by colons like 2001, 0DB8, 85A3, 00000000, 88E0370, 7334. This new format not only expands the address pool but also brings improvements in security and efficiency. Six addresses are written as 8 groups of 4 hexadecimal digits, separated by colons. For example, 2001, 0DB8, 85A3, 00000000, 88E0370, 7334. This structure allows for a much larger address space than IP4. IP6 also simplifies address assignment and routing, making networks more efficient. Additionally, IP6 includes features like built-in security and better support for mobile devices, which are essential in today's connected world. IP addresses are essential for communication on any network. They allow devices to find and talk to each other, whether it's your laptop connecting to a printer or your phone accessing a website. Without IP addresses, data wouldn't know where to go and the internet would be chaos. Every time you send a message, stream a video, or browse a site, IP addresses are making sure your data gets to the right place quickly and accurately. There are two main types of IP addresses: static and dynamic. A static IP address stays the same every time a device connects to the network. This is useful for servers or devices that need to be easily found. On the other hand, a dynamic IP address changes each time a device connects, which is more common for home users. Dynamic addresses are assigned by a service called DHCP, making network management easier and more flexible. IP addresses can also be public or private. Public IP addresses are used to identify devices on the wider internet, while private IP addresses are used within local networks like your home or office. Private addresses help keep your internal network secure and reduce the number of public IPs needed. Routers use a process called network address translation, NAT, to connect private networks to the internet using a single public IP address. Most devices get their IP addresses automatically using a system called DHCP, or Dynamic Host Configuration Protocol. When you connect to a network, your device asks the DHCP server for an address, and the server assigns one from a pool of available addresses. This process is quick and seamless, making it easy for devices to join and leave networks without manual setup. Static IP addresses, on the other hand, are set manually by a network administrator. Subnetting is a way to divide a large network into smaller, more manageable pieces called subnets. This helps improve network performance and security by limiting the number of devices in each subnet. Subnetting also makes it easier to organize and manage networks, especially in large organizations. Each subnet has its own range of IP addresses, allowing for more efficient use of available addresses. CIDR, or classless interdomain routing, is a way to write IP addresses and their associated routing information more efficiently. Instead of using traditional classes, CIDR uses a slash followed by a number to indicate how many bits are used for the network part. For example, 192.168.10.24 means the first 24 bits are the network part. This allows for more flexible and efficient allocation of IP addresses. Originally, IP addresses were divided into classes, A, B, and C, each with different ranges and purposes. Class A addresses were for large networks, Class B for medium-sized, and Class C for small networks. This system made it easier to organize networks but was eventually replaced by CIDR for greater flexibility. Understanding classes is still useful for historical context and some legacy systems. Loopback address is a special IP address that a device uses to send data to itself. The most common loopback address is 127001 in IP4. This is useful for testing and troubleshooting network software, as it allows you to check if your device's networking stack is working properly without needing to connect to another device. Broadcast address is used to send data to all devices on a network segment at once. In IP4, the broadcast address is typically the highest address in a subnet, such as 192.168.1255. Broadcasts are useful for sending announcements or discovery messages, but they can also create extra network traffic if overused. Multicast addresses allow a device to send data to a specific group of devices, rather than everyone on the network. This is useful for applications like video conferencing or streaming, where the same data needs to reach multiple recipients efficiently. Multicast helps save bandwidth and reduces unnecessary network traffic. Unicast addresses are the most common type of IP address. They are used for one-to-one communication between devices. When you visit a website or send an email, your device uses a unicast address to communicate directly with the server. This ensures that data is delivered only to the intended recipient. Some IP addresses are reserved for special purposes and can't be used for regular devices. For example, addresses like 0000 and 255.255.255.255 have specific roles in networking. These reserved addresses help manage network operations and ensure smooth communication between devices and networks. PIPA, or Automatic Private IP Addressing, is a feature that assigns an IP address automatically when a device can't reach a DHCP server. PIPA addresses are in the range 169.254.0.1 to 169.254.255.254. This allows devices to communicate on a local network even if there's no DHCP server available. There are several ways to assign IP addresses to devices. The most common is dynamic assignment using DHCP, which automates the process. Static assignment is used for devices that need a fixed address like servers. Some networks use manual assignment, where an administrator sets each address individually. Each method has its pros and cons depending on the network's needs. When you connect a device to a network, the DHCP server assigns it an IP address from a pool. This process involves a series of messages between your device and the server, ensuring that each device gets a unique address. DHCP makes network management much easier, especially in environments with lots of devices coming and going. Manual IP assignment is when a network administrator sets each device's address individually. This method is less common today but is still used for devices that need a consistent address like printers or servers. Manual assignment can be time-consuming but gives complete control over address allocation. Static IP assignment is similar to manual assignment but is usually configured on the device itself. This ensures the device always has the same address, which is important for servers, network printers, and other critical equipment. Static addresses make it easier to manage and access these devices remotely. Dynamic IP assignment is the most common method for home and office networks. Devices receive a new address each time they connect, making it easy to manage large numbers of devices. This method is efficient and reduces the risk of address conflicts since the DHCP server keeps track of all assignments. ARP, or Address Resolution Protocol, is used to map IP addresses to physical hardware addresses like MAC addresses. When a device wants to communicate on a local network, it uses ARP to find the hardware address of the destination device. This process is essential for data to reach the right device on a local network. NAT, or Network Address Translation, is a technique used by routers to allow multiple devices on a local network to share a single public IP address. NAT helps conserve public IP addresses and adds a layer of security by hiding internal addresses from the outside world. It's a key part of how home and office networks connect to the internet. IP address conflict happens when two devices on the same network are assigned the same address. This can cause connectivity issues as data may not reach the intended device. Conflicts are usually prevented by DHCP, but they can still occur if addresses are assigned manually or statically. Resolving conflicts quickly is important for network stability. Securing IP addresses is crucial for protecting networks from unauthorized access and attacks. Techniques like firewalls, NAT, and private addressing help keep networks safe. Regularly updating software and monitoring network activity are also important steps in maintaining security. Managing IP addresses can be complex, especially in large organizations. IP address management (IPAM) tools help track, assign, and monitor addresses across the network. These tools make it easier to avoid conflicts, plan for growth, and ensure efficient use of resources. Rapid growth of the internet has led to a shortage of available IP4 addresses. This problem, known as IP4 exhaustion, is one of the main reasons IP6 was developed. Organizations use techniques like NAT and subnetting to stretch their IP4 resources, but the long-term solution is to transition to IP6. Moving from IP4 to IP6 is a gradual process. Many networks run both protocols side by side in a setup called dual stack. This allows devices to communicate using either IP4 or IP6, ensuring compatibility during the transition. Over time, more networks and devices will switch to IP6 as it becomes the standard. 6 offers many advantages over IP4, including a vastly larger address space, improved security features, and more efficient routing. It also simplifies network configuration and supports modern technologies like mobile devices and the Internet of Things (IoT). As more devices connect to the internet, IP6 will become increasingly important. Despite its benefits, IP6 adoption faces challenges. Not all devices and networks support IP6 yet, and transitioning can require significant planning and investment. Training staff and updating equipment are necessary steps. However, the long-term advantages make the effort worthwhile. In home networks, routers assign private IP addresses to devices like laptops, phones, and smart TVs. The router uses NAT to connect these devices to the internet through a single public IP address. This setup is simple, secure, and efficient for most households. Business networks often have more complex IP addressing needs. They use subnets, VLANs, and static addresses for servers and critical devices. IPAM tools help manage these addresses, ensuring efficient operation and security. Proper planning is essential to support growth and prevent conflicts. Mobile devices like smartphones and tablets often move between different networks. They use dynamic IP addresses assigned by DHCP, making it easy to connect wherever they go. IP6 is especially important for mobile devices as it supports seamless connectivity and better security. The Internet of Things connects billions of devices, from smart thermostats to wearable fitness trackers. Each device needs a unique IP address to communicate. IP6 is crucial for IoT as it provides enough addresses for every device and supports efficient, secure communication. Cloud computing relies on IP addressing to connect virtual machines, storage, and services across the internet. Cloud providers use both IP4 and IP6 along with advanced networking techniques to ensure reliable and secure connections for users around the world. IP addresses play a key role in network security. Firewalls use IP addresses to allow or block traffic, and security systems monitor addresses for suspicious activity. Keeping your network's IP addresses secure helps protect against unauthorized access and cyber threats. When network problems occur, checking IP addresses is often the first step. Common issues include address conflicts, incorrect settings, or DHCP failures. Tools like Ping and Traceroute help diagnose and fix problems, ensuring devices can communicate smoothly. The future of IP addressing is all about scalability, security, and supporting new technologies. As more devices connect to the internet, IP6 will become the standard. Innovations in networking will continue to improve how we assign, manage, and secure IP addresses for years to come. Let's recap what we've learned about IP addressing. We covered the basics of IP4 and IP6, how addresses are assigned, and the importance of security and management. Understanding these concepts is essential for anyone working with networks, whether at home, in business, or in the cloud. IP addressing isn't just theory, it's used every day in real-world scenarios. From setting up your home Wi-Fi to managing enterprise networks, understanding IP addresses helps you troubleshoot problems, secure your data, and keep everything running smoothly. IP addressing is just the beginning of networking. There's a lot more to explore, including routing, switching, and advanced security. Building a strong foundation in IP addressing will make it easier to understand these advanced topics and grow your networking skills. Thanks for joining us on this journey through IP addressing. With a solid grasp of these concepts, you're well equipped to tackle more complex networking challenges. Remember, every device you use relies on IP addresses to connect and communicate. Keep exploring and you'll discover even more about the fascinating world of networking.